Hello, this is Scholar Strive doing some math today. In Algebra 1, we'll be looking at more factoring. So the only difference from last time is we're adding a value. A value right in front of the x squared term. So for example, in number 1, a equals 2, b equals negative 11, c equals 5. And we're going to do things a little bit differently. So instead of finding just factors of c, we're also going to find factors of a value. So factors of a, which is 2 in this case, and we're going to find factors of c. So we're still going to create, x here, but it's going to change. So my factors of a, they go in these two spots, number in front of x. And there's only one factor, 2 and 1. We can go negative 2 and negative 1, but for factors of your a, you just want to keep them positive if possible. Just makes it easier. So this is 2 and 1 right here. So now we need to figure out c values. So we have 5 and 1, and negative 5 and negative 1. So notice our b value this time is negative 11x. Our factors of c, none of them add up to negative 11. That's because of our a value. Our a value changes things. And I'll show you why. So what you want to do here is pick numbers that you think will work. So it's a negative 11x, so it's probably going to be some combination of negative 5 and minus 1. In fact, it's actually this one, and I'll show you why. So when we check, we FOIL this. These first numbers here, that gives us our 2x squared. So we're on the right track. So that's how we get our a value. Our outside numbers, that'll give us minus 10x. Our inside numbers, so our outside and our inside numbers determine our b value. And then our last numbers determine our c value. So when I add this all together, I'll get 2x squared minus 11x plus 5, which matches our original equation. So we know that this right here is correct. So let's do this again. Okay, a values, factors of a, factors of c, and we're creating x times quantity x. So factors of a, so a is 5, so we have 5 and 1. And for a, we just like to keep them positive, so I have a 5x here and a 1x over here. Okay, let's look at our c factors. We have negative 3 and positive 1, or 1 and negative, positive 3 and negative 1. That are the only two choices that'll give us negative 3. So we need to figure out which combination. So it takes some trial and error, but eventually, as you get used to these, you'll find out that we remember that this number here, our outside and our inside numbers, this 5x is going to be being multiplied whatever this red number happens to be. So that's going to give us a positive 5x in our outside numbers. Our inside numbers will give us a minus 3x, which gives us our b value, which is 2. Now if we want to do a full check, first numbers, 5x and x, that gives us our 5x squared. So everything's looking good for so far, and our red numbers determine our last numbers, determine our c value, minus 3. So we are good. So this multicolored expression up here is our answer. This is factored. So let's do some more. Okay, we have x, x. Oh, be careful though, because we tend to use x a lot, but remember our variables can be anything, and in this case they used n. So I would change everything in here to n. Let's just say those are n's. Okay. So these are x's. So factors of a go here. Factors of a go here. 3 and 1. Okay, factors of c, we have 2 and 1, and negative 2 and negative 1. So most likely it's going to be a combination of negative 2 and negative 1, because we're going to add them up and get negative 5 here. So in this case, it's going to be minus 2, minus 1. Let's try out that. So first numbers, I'll get 3x squared. Outside numbers, I'll get minus 3x. Inside numbers, I'll get minus 2x. And last numbers, I'll get positive 2. And it works out. So this is my answer. Okay, we're dealing with m's this time. So factors of 2, we already know that's 2m and 1m. All right. So when we have to pick factors of negative 21 here, so I can have 7 and minus 3, 3 and minus 7. It's probably not 21 and 1. So it's one of these combinations of 7 and 3s. Well, we know our b value is positive, so it's most likely the one being multiplied by 2 is negative. But that's actually not the case. The one that's actually being multiplied by 2 is negative 3, because if we look at first, well, that's 2m squared. If we look at our outside numbers, we'll get minus 6m, and then our inside plus 7m. Lastly, minus 21. It works out that way. So it just requires some trial and error and some practice, and you'll get to where you want to be. Okay, now we have a negative 4x squared plus 4y plus 3. So whenever you have a negative a value, this is what you want to do. You want to factor out the negative. So I'm just going to put negative on the outside, and that'll change everything inside. This will now become a positive 4x squared. This will become a minus 4y, and this will become a minus 3. So now I'm working with a positive a value. So I'll just do the same thing, negative. So the negative's outside now. And we just factor like normal. So x and x. Now here's a problem though. We have multiple factors of a now. Usually we just dealt with 1. But now we have factors of 4. We have 2 and 2. And 4 and 1. So how do we determine which one works? For now, we just have to do trial and error. So here's my factors of A. We have 2 and 2, 4 and 4. To speed up some time, it's going to be 2x and 2x. But that's after trying out different combinations. If we look at our C value, we have -3 and 1, and +3 and -1. So not that many combinations to go through. -3 plus 1. Let's try that. So I'll do... So we have a negative outside. And then we'll get 4x squared. Outside numbers, 2x plus 1, or 2x times 1 is plus 2x. Then we get -6x. And we get our -3. And if we apply the negative, we'll get -4x squared plus 4y plus 3. So we worked out there. So my answer is this here. This is my factored form. What I did on the bottom was a check. I checked it out. I folded it to make sure I got the original equation. Alright, let's take a look here. Okay, -2y squared, so I'm going to factor out a negative, and this becomes 2y squared plus 11y plus 5. Okay, factors of A, a lot easier this time. So 2y and y, 2 times 1 is 2. So that's our A factor there. Factors of C, we got 5 and 1, but where do we put 1 and 5? So we know that these outside numbers are going to be multiplied together. So 2y times this number 5 is 10 plus another y. But just to be sure, let's FOIL it. So I have -2y squared plus 10y plus 1y plus 5. Okay, when I apply the negative, I'll get -2y squared, which matches, minus 11y, which matches, minus 5, which matches. Alright, example 4. An athlete hits a tennis ball at an initial height of 8 feet with an initial velocity of 62 feet per second. Write an equation that gives the height in feet of the ball as a function of time in seconds since it left the racket. So h, the height after a certain amount of time, is equal to -16t squared. So this comes from that formula from a while back. Plus vt plus our initial height, which is an s. So we put in all the numbers we know for right now. And because we're trying to create an equation, h equals -16t squared plus vt. So v is initial velocity of 62 feet, so plus 62t plus our initial height of 8. So that's my equation. Now they want to figure out after how many seconds does the ball hit the ground. So we know that the ground level is 0. And so we have -16t squared plus 62t plus 8. Okay, now these are some big numbers. We have to find factors of A, factors of C, and it's going to get very time consuming. But notice they all share something. They're all multiples of 2. So I'm going to factor out a negative 2, because 1, I don't like my a value when it's negative. So I'll have negative 2 times 8t squared, so 16 divided by 2, that's where that comes from. And this is going to be minus 31t minus 4. Okay. Now this is still a little bit harder, but what this factors into is 8t plus 1, t minus 4. Because if, wait, oh, sorry. Well, yeah, okay. So when I factored out all of this, my new a value is now 8, my b value is negative 31, and my c value is negative 4. So this is pretty tough, because if we look at factors of a, we'll get 8 and 1, 4 and 4, or 4 and 2, I mean. And that's a lot of combinations. And then factors of c, negative 4 and 1, positive 4 and negative 1, 2 and negative 2. So that's a lot of combinations there. But after some trial and error, this actually comes out to be, so factored, so that we have the negative 2 on the outside, and then we're factoring this. This actually comes out to be 8t times the quantity, t minus 4, and this one is plus 1. So if we look at both of these, we'll get either 8t plus 1 is equal to 0, or t minus 4 is equal to 0. So if I look at t minus 4 equals 0, then t equals 4 seconds. If I look at 8t plus 1 equals 0, I'll get 8t equals negative 1, and then t would be negative 1/8 seconds. And since time is positive, this answer is incorrect. So we only have one answer of t equals 4 seconds, because it only makes sense that the ball hits the ground once. I mean, it bounces, but that's a bit different. That requires a different formula. In example 4, suppose another athlete hits the tennis ball with an initial velocity of 20 feet per second from a height of 6 feet. So we're just doing the same equation again, negative 16t squared, but this time we have plus 20 feet per second and from a height of 6. Okay, so I'm going to factor out a negative 2 again, because they're all multiples of 2. So 8t squared plus 10t plus 3. And since I factored out a negative 2, this positive now is a negative. And this positive 3 is now also a negative. Alright. And this is equal to 0. So I'm going to factor this. And this, so factors of A. So factors of A are the same, but factors of C are different. We have 3 and negative 1. Now don't be confused, we're working at this A, this B, and this C. A is 8, B is negative 10, C is negative 3. So factors of C, we have 3 and negative 1, and negative 3 and positive 1. This comes out to be 4t plus 1 times 2t minus 3. So either 4t plus 1 equals 0, or 2t minus 3 equals 0. This one is not going to be, because it'll be negative. This one will be 2t equals 3. So t equals 3 halves, so 1.5 seconds. All right. Hopefully this helped you out. Have a good day.